Okay, so I'm just going to go through this pretty quickly. The derivative of sine is cosine, and then times cosine of u du. So the derivative of u is 3. So that would be e. Number 2, notice if you plug in 0, anytime you're going towards a constant, your first step is to plug it in. So if I plug in 0, notice that this is 1 and this is 1, so I get 0 over 0, which means I need to do L'Hopital's rule. And so you do the derivative of the top, which is e to the x, plus sine x minus 2 over the derivative of the bottom, 2x minus 2. Plug in 0 now. Over 2 times 0 minus 2. So you have 1 minus 2 over negative 2. So 1/2. Okay, so this is u substitution, because u is 3x plus 1 and the derivative of u is 3. And so we just need a 1/3 in front, and then you increase the power by 1 and then divide by it. So if you need a review on u substitution, you can go back and look at those notes. Big idea is we're kind of undoing the chain rule. The chain rule has been done, and there should have been a 3 sitting out here, but there wasn't. So we had to divide by the 3. So parametric equations, and it's what is the slope of the line. Anytime it asks for the slope of the line, it's asking for dy dx, whether we're talking about polars or we're talking about vectors. And so this is dy dt over dx dt. So I always like change in y over change in x. So dy dt, the derivative of y would be 4 cosine t, dx dt would be negative 3 sine t. Cosine over sine is cotangent, or that would be the same as tangent in the bottom. And we're going to evaluate this at 13, so our answer is D. Okay, Euler's method, we have a differential equation given to us. Starting at 1, we're moving to 2 with a step size of 0.5. So basically you just do point slope multiple times. So 1 comma, does it tell us what? 2. Slope, we use the differential equation. At 1, 2, we have 1 plus 2, so 3. So y minus y1 equals the slope times x minus x1. Or y equals the slope times x minus x1 plus y1. So I'm going to use this form just because it's easier to plug into. So y equals the slope 3 times x minus 1 plus the y coordinate. Now I'm stepping by 0.5, so add 0.5, so that'd be 1.5. To figure out what goes here, you plug 1.5 in here. And your change here should always be a change in x. 3 times 0.5 plus 2. This is 3 times a half, so 3 halves plus 2. So we have 1.5 plus 2, 3.5. And so then you do point slope again. So find the slope at 1.5 comma 3.5. It's just adding them together. 1.5 plus 3.5 gives us 5. And so y equals 5 times x minus 1.5 plus 3.5. And then you step by 0.5 again. So now you have 2. 2 minus 1.5 plus 3.5. So 2 times 0.5 plus 3.5. So half of 2, 5 times. Oops. 5, half of 5 is 2.5 plus 3.5 is 6. Okay, so this is like the series 1 over n to the 2p. We know that whatever is right here needs to be bigger than 1. And so p must be greater than 1/2. You recognize this is kind of like the integral test. When is the particle at rest? Anytime you see this, you should think velocity equals 0. Well, if we have 2 directions, that means that dx dt must equal 0 and dy dt both must equal 0. And, okay, so take the derivative of x, because if one of them is not, that means it has either horizontal or vertical motion. 3t, so t minus 2. And then find dy dt, this is vertical, then motion in the vertical direction. So we have 6t squared minus 6t minus 12. t equals 2, t equals negative 1, so we have time equals 2. Okay, so you might see this and think integration by parts, but it's not, because look at here, this derivative, if u is x cubed, du is 3x squared. So this is part of the derivative sitting out here. We're missing the 3, so we need 1/3, so it's 1/3, and cosine goes to normal sine, x cubed plus c. So that is right here. Okay, derivative of natural log of u is 1 over u prime, or du. So the derivative of u is 1 plus 0 minus 3 e to the negative 3x over u. So 1 minus 3 e to the negative 3x over x plus 4 plus e to the negative 3x evaluated at 0. So 1 minus 3 e to the 0 over 0 plus 4 plus e to the 0. Negative 2 over 5. So you should see this in the geometric series. You need to write it in a way where, so to separate this is like 2 to the first times 3 to the n, 3 to the n. So this is 2 times 2/3 to the n. And so our r is 2/3, so this converges because it's less than 1. The sum is the first term over 1 minus r. Pay attention to where you start. Sometimes it's at 0, sometimes it's at 1. If we start at 1, that means our first term is 2 times 2/3, which is 4/3. So 4/3 over 1 minus 2/3, so 4/3 over 1/3 gives us 4. Maclaurin series, this is a power series. You recognize it as a1 over 1 minus r. So this is r, and this is the first term. And so if you think about it, it's just a1 plus a1r plus a1 times r squared plus a1 times r cubed, etc. So we're just multiplying by r. So if you look at this, this is our first term, and then it's minus r. So r equals x squared. So we're just multiplying, which means we're adding exponents. So we get this one, d. This is just putting this in order. Rate of change of volume, dv dt, is directly proportional to means k. Square root of the volume means square root of v. So that is just e. Continuous but not differentiable. So basically you don't ever pick up your pencil, but it's a sharp turn or some vertical tangent line. So if you look right here, it's continuous because the limits match. This is not continuous limit, but the limit and the value don't match. This one, the limit doesn't exist. From the left and right are different. So here we have a sharp turn, but it is continuous, so that is A. Okay, slope field. We look at this, and it's kind of tricky, but if you think about the signs, if x over y is kind of circular, so I kind of just remember that one. But if you look at this, you notice that if this was the case, whenever you have a negative over a negative, you should have positive slopes. So over here in the third quadrant, you should have positive slopes, and that's just not the case. Here you would only have positive slopes, and that's not the case. Here you would have the same idea here, because odd over odd, again, that's not the case. Even over odd, so that means that the only thing that's going to affect it is the y coordinate. So if y's were negative, it would be negative, and that's not true. And so you look at e, and it's x cubed over y squared, so this is always positive. So right there would be positive slopes, and to the left there would be negative slopes, which that is the case, so it's e. Length of a curve, this is just knowing the formula. So it's 1 plus f prime of x squared. So you're going backwards, you're taking the square root of this, which would be 3x squared, and the antiderivative of that, which would be x cubed plus c. And so the point is 1/6. And so if you kind of test it out, b works because x cubed, if you do 1 cubed plus 5, you get 6. Okay, line tangent to the graph. 1/7 passes through this point. This is kind of tricky for some people. This derivative means instantaneous rate of change, or the slope of the tangent line. And so basically this is just telling you have some curve. We don't know what it looks like, but we know that the point that passes through 1/7 also passes through this other point down here, negative 2, 2. And so I can find the slope of the tangent line by just doing delta y over delta x. So negative 2 minus 7 over negative 2 minus 1, negative 9 over negative 3, 3. Equation of the line tangent. So I need point, slope, point negative 3, 8, slope, dy dx. So that's dy dt, which is 3t squared over dx dt, which is 2t minus 4. Gotta figure out what time is, because these are x and y value. Well, if y is 8, that means the time must be 2. And what happens when I plug in 2? Well, you get a little problem. You get 12 over 0. It says, no, this means that there's a vertical line. The way you get vertical lines is x equals whatever the x coordinate is, and that is negative 3. Okay, here you have a function, and notice the function is an integral. So the derivative is the second ftc, which means you do the derivative of the top, so 2, and then you plug this in, f of 2x. We're evaluating this at 3, so 2 times f of 2 times 3. So 2 times f of 6, you look and see what f of 6 is, negative 1, so 2 times negative 1, negative 2. Equation for this curve. Okay, so a lot of times you see equation, you think point slope, because I've trained you so well. But in this case it's a little different because it asks for the equation of this curve. So the slope is dy dx, 2x plus 3. And then you separate and integrate plus c, solve for c, solving the differential equation. So x squared plus 3x plus c, this is a curve. We're trying to figure out the equation of the actual curve. It's the difference between figuring out this versus this. In c, you use your initial condition, 1 plus 3 plus c should be 2. So c must be negative 2, so must be d. Maclaurin series. Okay, notice the bottom. We should know e to the x is the one that has all of the factorials. And we know that cosine of x is the one that has, it's alternating and it has the even factorials. We know that sine of x is odd and also alternating. So you should notice that this one is not alternating and it has every factorial. So it looks like it would be e. So you can kind of work backwards. You have e to the x. How could you make it say x to the 4th, x to the 5th? Try, is it e to the x squared or is it x squared times e to the x? Well, this term is what tells you the difference. X squared could be either, if I plug in x squared or multiply by x squared, I could get x to the 4th. But only if I multiplied through by x squared would I get to this term, x to the 5th. And so that means that we're multiplying by x squared. And so if you multiply through by x squared, you get x squared plus x cubed plus x to the 4th over 2 factorial plus x to the 5th over 3 factorial, etc. So you have these extra terms that you don't need, and so you subtract them out, which is part D. So we have logistic differential equation, and you need to know that the general form is kp times L minus p, and so we need to get just p right here, or just in this case n. So you're factoring out, you're dividing by 1 over 200, which is the same as multiplying by 200 over 1. So you're pulling out 1 over 200, so 6n over 200, 1 over 200, you're multiplying by 200 over 1, so 200 minus n. And so this right here, what sits right here is your limiting number. And don't forget, it's growing the fastest at half of that. The point of inflection would be at 100. The limiting number is 200, that's for the vertical asymptote. So if you just kind of want to think about, we have the vertical asymptote, the starting conditions at 50, and then it would have the point of inflection at 100 and approach it. It can approach from this way. It doesn't have to have a point of inflection if the initial condition was above 100. Okay, so this is kind of thinking through, what if this was like n over n squared? You can compare it to 1 over n, because you do the difference here, and this b equals 1, so this diverges. So you need this to be something like 3, so then the difference here would be 2, and so this would be p equals 2, and so this would converge. So basically, hopefully you see that needs to be greater than 2, just kind of thinking through it, but you could just realize you're going to compare it to n over b, which is the same as 1 over n to the p minus 1. So p minus 1 must be greater than 1. And so p must be greater than 2, cannot equal 2. Okay, so we notice that this is two functions, and they don't really, the derivative is not one of the other. And so this is, flip it, integration by parts. So u is x, du is dx, dv is sine of 6x, and v, the antiderivative, would be 1/6, negative 1/6 cosine of 6x. And then you do u, v, minus the integral of v du. And so the antiderivative would be negative x over 6 cosine of 6x plus 1 over 36 sine of 6x, because you have to divide by another 6. You could do the table here because the derivatives go to 0. You can do the table if you have pet sine of 6x, negative 1/6 cosine of 6x, negative 1/6 sine of 36 sine of 6x, and then it's plus minus, and you would do diagonal. This is geometric. Sine of 2 over pi is less than 1 because this is between 1 and negative 1, and that's 3.14. Here p equals 1/3, that's less than 1, so this diverges. This is, if you take the limit as n goes to infinity, hopefully you see this is the same power. On a to the n, even the n is going to grow at the same rate, you get 1. This is not 0, so this is the nth term test for divergence. And so 2 and 3 both diverge, which is D. Right hand Riemann sum. Notice these are unequal subintervals. So we need to kind of just draw it out. I think that's the safest thing. 2 to 5 to 10 to 14. So this is a difference of 3. Right hand means you do the right hand. Oops, sorry, that's left. Right hand would be using 5, 10, and 14. So 3 times 28 plus 5 times 34 plus 4 times 30, which gives us, number 25 is B, so it should give us 374. When you see fractions, you should think partial fractions. When you see factors, think partial fractions. If you are able to easily factor the denominator, so multiply 3 by x plus 3 times x plus 1, we get a times x plus 1 plus b times x plus 2. Let x equal convenient things like negative 1. So negative 2 equals, if I let b be 2, negative 2 equals b. And if I let x equal negative 1, I get negative 2 equals negative 2a. I let it equal negative 1. Let x equal negative 2. So I get negative 4 equals negative a. So a equals 4. So we get 4 over x plus 2 minus 2 over x plus 1, and we're integrating these. So natural log of x plus 2 minus 2 natural log of x plus 1 plus c, which is this one. Derivative of an integral. Hopefully all of you right now automatically associate this with second fundamental theorem of calculus. Take the derivative of the top, plug it in. Natural log of x cubed squared plus 1. So that would be coefficient of x squared. Okay, so we're going to figure out what x squared would be. So the original function is 1 over 1 plus x quantity squared, or 1 plus x to the negative 2. And so the derivatives aren't going to be bad because the chain rule doesn't really matter because the derivative is 1. So f double prime of x would be 6, 1 plus x to the negative 4. And so we're valuing this at 0, so f double prime at 0 would be 6. And then think about in your graph, it's 6, in your formula, it's the second derivative times x minus c to the second power over 2 factorial. So this is what's in front. 6 over 2 factorial, which is 3. Only 39% of the people got that right. So hopefully that won't be it. Okay, so part B. Which of the following must be false? F of A exists. No, that's true. It exists. Stop. F of X is defined between 0 and A. That's true. It is defined between 0 and A. F of X is not continuous at X. That's true. It's not continuous because the limit doesn't equal the value. The limit as X goes to A exists. That's true because the limit from left and right exists. If I approach the same thing, the limit, we don't know anything about F prime. F prime of A does not exist. So the limit as X goes to A, F prime of A doesn't exist. So let's see. Third derivative. Okay, a lot of you missed this on your test. Third derivative means look for the x cubed. So negative 5. But don't forget, this is like over, it's f to the n factorial over n factorial. We're trying to figure out what just this part is. And so in this case, we need to multiply by n factorial. And whenever we're doing this, so we need to multiply by 3 factorial. So negative 5 times 6 is negative 30. Radius of a circle is increasing, so dr dt, 0.2 meters per second. What is dA dt when circumference is 20 pi? That is the same as r being 10. So we need to relate these. We relate them as pi r squared. You take the derivative with respect to time, and then you plug in stuff that you know. 2 pi times, 10, and then dr dt is 0.2, and so we get 4 pi meters squared per second. H prime of 1. So this is the chain rule. F prime of g of x times g prime of x. So f prime of g of 1 times g prime of 1. G of 1 is negative 1. So f prime of negative 1 times g prime of 1. F prime of negative 1 is 5. And g prime of 1 is 2. And so we get 10. How many tons? How many? They gave us a rate and they asked for how many. So you integrate the rate to get the amount. And so we just integrate this from 7 to 14 using Math 9 in our calculator. Okay, Math 9. 100 e to the negative 0.3x divided by parentheses 2 minus e to the negative 3x, close your parentheses, comma x, comma 7, comma 14. Did I do something wrong? Oh, negative 0.1. If you made a mistake, you can push second enter to pull up your entry. And this is negative 0.1, not 0.3. So I get 124, which is almost 125. What is the value of the limit as x goes to 1 of sine of x? Since sine is continuous, this is the same as saying the sine of the limit as x goes to 1 of f of x. What's the limit as x goes to 1? Well, it's where you're approaching. You don't care about where the dot is. It's where you're approaching. You're approaching 2. So this is just the sine of 2, which you can evaluate in your calculator. The sine of 2 is 0.909. The rate of change, okay, so this actually is the rate of change of altitude. It's like the altitude derivative, a prime, if you will. You want to know when the altitude is decreasing, so that's where a prime would be negative, or the rate would be negative, below the x-axis. And so if you graph this in your calculator, and you look to see where it's negative, you have x cubed minus 4x squared plus 6, and then you graph, zoom, oh wait, yeah, zoom, now I want to change my window, 0 to 8. And you're going to see where it's negative. My y's are kind of off. Let me change them. Negative 1 to 4 to negative 5 to 5. Okay, so we want to figure out just where this guy is negative, which is this part right here. So you can probably guess what that is. It's somewhere in between 1 and 2, so that would be 1.572. We can also find the 0. Okay, we don't know what happens in between all these values, so we can't know the minimum is 2 or the maximum is 4. We can't know that we're always greater than 0. F prime is less than 0 from 2 to 4 is f. If f prime is less than 0, that means f is decreasing from 2 to 4, and it's not always decreasing. This is the mean value theorem. We have continuous and differentiable, so that automatically means this applies. Now, you always do f of b minus f of a over b minus a. This is what f prime of c is guaranteed to be. So 2 minus 2 over 4, 0 over 4 is 0. So that one is true. Speed is the square root of the change in x squared plus the change in y squared. So this 2t squared plus 4 cosine of 4t squared evaluated when t is 3. I trust you can plug that in the calculator for time's sake, so the answer is C. Trapezoidal sum. You could draw one big trapezoid if you want, so you can easily see this is an over approximation. Right hand means you go, say I had 2 subintervals. It doesn't matter how many subintervals, the idea of over and under is going to be the same. You use the right hand point and draw over. And so this would be under, so A is our answer. Points of inflection, you should think f double prime changes signs. Or that's the same thing as saying f prime changes direction. Okay, so what this means is you have an option. You can grab the second derivative if you want, which would be 3x squared cosine of x cubed, and see where this crosses through the x-axis. Or you can graph the first derivative and count the maxes and the mins, because these things correspond. So I think it's probably easiest just to graph sine of x cubed. Make sure you check the window. Windows from negative 1.8 to 1.8. And then counting the maxes and the mins. 1, 2, 3, 4. So it looks like there's 4 to me. If you want to be certain, you can go back here and you can graph the derivative. You can even let your calculator do it. Math 8 bars, y bars. And under we're taking the derivative of what's in y1, which is the first derivative. So this would be the second derivative. I'm turning off y1 and then graph it. This is kind of the time it crosses through the x-axis. 1, 2, not that one, because it doesn't actually cross. 3, 4. So it has to actually change. So there's 4. What position was the position? So PVA when the velocity is first equal to 0. So graph the velocity. Cosine of 2 minus x squared. Window just has to be greater than 0. First 0 is right there. So I'm going to find that time. Second, trace 0. Enter, enter, enter. So we get time equals 0.655, etc. Then we want to find the position at that time. Well, this is the fundamental theorem of calculus. The integral from 0 to 0.655 of velocity would be equal to the position. It's the antiderivative of a, or b, minus the antiderivative at a, which this is 3. It's 3 at the time 0. So if I solve for this, which is what I'm trying to find, it's 3 plus the integral from 0 to 0.655 of the velocity. Or you can think about ags. It's like you know that you're starting with a velocity, a position of 3 at time equals 0, and then you're adding and subtracting as you accumulate, as you move to the right. So I need to go to my home screen and do math 9, vars, inner, comma x, comma 0, comma, I forgot to store it, but it should be x still, plus 3, so 2.816. It was still x, because on my graph I hadn't changed what I had traced it to. Alright, this one, if you notice this is 1 over 2, then I'll go from 2 to 4 of f of t dt. This is the average value. It's saying the average value is 1. But I could solve for this, like treat it like a big variable, by multiplying by 2. So that means that the area, should just equal 2, and you can just figure that out geometrically. So geometrically, if you notice, this is 2 triangles, each have an area of 1, and 1 plus 1 is equal to 2. Okay, if you graph this, you can graph it in your calculator. If you factor out 2, it's x. If you factor out 2x, factor out 2x, then it is 1 minus x. So we have intersection points at 0 and 1, so it looks like this. And we have cross sections perpendicular to the x-axis. So we're integrating from 0 to 1. It's always top minus bottom here. And that would be just the function itself minus 0. And the area, that's how you do for cross sections. You integrate the area of one slice. You just focus on one slice. And so the area of equilateral triangle is s squared to 3 over 4. So we're just going to do 2x minus x squared, square roots of 3 over 4. And you put this in your calculator, but using math 9, you should get 0.462. Which of the following must be true? Okay, so this is the derivative of the function. F of 0 is 0, so I start with 0 as I accumulate. F of 0 is greater than f of 1. That cannot be true because you're accumulating area. F prime is positive this whole time, which means f prime must be increasing. So this is not true because 1 must be greater. F of 2 is greater than f of 1. This is true because f prime is positive from 1 to 2, so that means f of 2 must be greater than f of 1. You're increasing, you're accumulating all this area. This is also true. F of 1 is greater than f of 3. We don't know because I add this area, but then I also subtract this area, and I don't know for sure if this addition minus this is the same as this or not. So this one is maybe, but it says which one must be true, and so that is 90 is B. Okay, so we have height, it asks for maximum velocity. Anytime you maximize anything, you look at this thing's derivative, which in this case is actually acceleration. So we take the derivative of this, that's 24 plus, I think it was 36 t to the 1/2 minus 30 2t. H dou prime of t is 18 t to the negative 1/2 minus 32. And so if I graph this, I'm trying to see where it goes from positive to negative because that would be a maximum. And you can also let your calculator do this as I've shown you previously. If you do y1 and then math 8, this would be the second derivative. Let's see what's in the window. That should be fine. Okay, so this is the max, positive to negative right here. So second trace 0. Look at my y's. Notice it was negative 20, so I need to arrow to the left to make it come up till it appears on my screen finally. Okay, inner, and then go below, inner. So it's at 0.316. That is my x value right now, so I can just type it into my height because it's asking for the height of the position. 24x to the 3/2. Again, you can store this, but since I'm only using it this one time, otherwise it's not good practice to use x because x always changes. I'm just using it once, so that's why I did that. Okay, instantaneous rate of change, the same as the average rate. Instantaneous rate of change, we're just doing what it says, is the same as the average rate of change. F of 4 minus f of 1 over 4 minus 1, which you can figure this out in the calculator. F of 4 would be 4 plus natural log 4. F of 1 is 1 plus natural log 1, which is 0. So we're trying to figure out where 4 plus natural log of 4 minus 1 over 3, that's the same as 3 plus natural log of 4 over 3 equals 1 plus 1 over x, which we can solve this by hand, or we can put it in the calculator. 1 plus 1 over x, and then parentheses 3 plus natural log of 4 parentheses over 3. Graph it. We're trying to see where they intersect. Intersect right here, which you can kind of see a little bit more than 2, but we want to be sure. So second trace 5, enter, enter, enter. We get 2.164.